Okay, welcome to Mastering Blockchain Architecture. And we're going to start off our first week with the foundations of blockchain architecture. So let's go in to our slide into the fundamentals of blockchain. What is blockchain? Now, at its core, a blockchain is a distributed ledger that records transactions across a network of computers in a secure, immutable, and transparent way. So unlike traditional databases, blockchains are decentralized, which means no single entity controls the network. It's immutable, which means once written, data cannot be altered without the network's consensus. And transparent, which all transactions are visible to the network participants. And that really depends on the type of blockchain, whether it's public or private, but it is transparent and you can see the transactions going on. Let's talk about the components of a blockchain, starting off with a ledger. So a ledger is a sequence of blocks containing transaction data. Now, blocks are cryptographically linked to ensure integrity. And when we say cryptographically linked, it just means that blocks of data are connected in a way that makes them super secure and tamper-proof using these math-based locks that we call hashes. More of components of a blockchain, let's talk about nodes. Nodes is simply computers. They're computers that are connected to the network. Now, these can be full nodes, which store the entire ledger, or light nodes, which stores partial data, the partial ledger. Now, consensus mechanisms are a really big part, really big component of blockchain. And it just ensures agreement of the state of the ledger across all the nodes, all the computers. Now, the examples of some consensus mechanisms are proof of work, proof of stake, delegated proof of stake, and even practical Bayesian fault tolerance. These are some of the things we'll dive in a little deeper in this course, but this is just examples of consensus mechanisms, which again, is just agrees. We're just ensuring that we all agree about the state of the blockchain. And the last component of blockchain is cryptography here, which is used for securing transactions and controlling participant access. And they use these hashing functions to ensure that data integrity is good. And that hashing functions would be in an algorithm SHA-256. Now, just to go in a little bit with these three types of cryptography. Okay, so basically symmetric is just one single key is used for both the encryption and the decryption of the message or the data. And then we have asymmetrics, which is used two keys to unlock the data, one to encrypt it, one to decrypt it. And that's usually what we call a public key cryptography. And the hash functions, we talked about the SHA-256. Hash functions is just converts data into a fixed size string of random characters, which we call a hash. So it takes a regular plain text like hello, and then we implement SHA-256 or a type of algorithm, a hash functions algorithm, and it comes out into a hash text, which is random letters and numbers, okay? So these are the types and the three that you will see as we continue on in the course, but at least you know the basics. Now, there are four main types of blockchain technology. We have a public blockchain, which is a fully decentralized and open to anyone. Think of Bitcoin or Ethereum. We have private blockchain, which is controlled by a single organization with restricted access. If you already have some blockchain knowledge, you would know that that's something like Hyperledger Fabric, which IBM uses. And then we have consortium blockchain, which is semi-decentralized and is controlled by multiple organizations. Think of Corda. And we have hybrid blockchains, which just combines the elements of public and private blockchains for that flexibility. Okay. So as you go out there, you'll see that there are different types of blockchain networks, and they'll fit into one of these four main types: public, private, hybrid, or consortium. Now let's talk about the anatomy of a block. So we have two things. We have a header, which contains the hash of the previous block. We have the timestamp, the nonce. Nonce is really for proof of work systems. So that's when you'll see that. And then the Merkle root, which is really just a hash summarizing all the transactions in that block. Hash of block data, that's the Merkle root, which we'll go in a little bit more. Now, underneath the header, we have the body. And the body is literally just a whole bunch of transactions or data that's stored in the block. Okay. Now I kind of want to break down the anatomy of the block and blockchain a little bit more in detail. So let me go back over here. We have the header and the body. In the header, the hash, the first thing it's going to start with is the hash of the previous block. So it's this cryptographic hash, this fingerprint that is nothing but just the previous block's header. Okay. And it assures that the blocks are linked together in this chain. All right. So if any data in the previous block is tampered with, the hash will change, and then it will break that chain and it will alter the network. So that's with the hash, the previous block header hash. Underneath that is the timestamp, which is the exact date and time when the block was created. And this helps in maintaining the order of the blocks. Okay. Next, under timestamp is the nonce. Remember, that's more proof of work consensus, but it is a random number that's used in that consensus mechanism. And basically, miners, people who will mine in the network, use their computers as nodes, they can change the nonce repeatedly until they find some type of hash value. And this hash value needs to meet the network's difficulty. All right. When we get to proof of work, we'll talk more about nonce. We'll actually start building some things. We can see it in real time. But at least you understand that this nonce is a random number that's used in the proof of work consensus. And it's just a basically a hash value, right? Just think of it as a hash value for easier sake. Under that nonce is the Merkle root. That Merkle root is a hash of all the block data. So it's just a single hash, and it summarizes all of the transactions in the block. Okay. And again, it's going to be generated by using which we call a Merkle tree, which is just a data structure that organizes and hashes transactions in certain pairs. All right. This Merkle root or this Merkle tree, it allows for quick verification of whether a specific transaction exists or doesn't exist in the blockchain. All right. And for the proof of work blockchain, they do have this difficulty target that'll be in the header as well. But when we get to that part, I'll pull back up the anatomy of the block. But until then, just make sure you understand these four things that's in the block header, regardless of what network you're in. Now, the block data, the block body, this contains the actual data or transactions that's being recorded in the blockchain. So think of it as the content of the block, okay? So the block header is like the ID card. The block body is the content of the block. And it just lists the transactions, all the transactions that's included. Each transaction contains things like sender and receiver information, the amount that's being transferred, and a digital signature to verify that it's authentic. In most public blockchains, there's a limit to the number of transactions a block can hold. So think of it like Bitcoin. They can only hold a certain limit. I think about 1 megabytes, I believe. I can check, do a little research, but just know that there is a limit in Bitcoin blocks as far as how much transactions they can hold. And also in the body, there's other data as well, just depending on the blockchain. Other data can be smart contract code. So think of like Ethereum. Other metadata like messages, notes, or rewards from the miner that's actually validating these and stuff. So uh, there's a lot of things in the body, but just make sure you understand that it's really just a list of all the transactions and the details of those transactions. Okay. The point of all blockchain is really for you to understand everything is transparent, no one can change it, and you do not have to directly know the person, trust the person, because the blockchain makes everything transparent and makes everything secure and safe. Okay. So that's the anatomy of block. Like I said, I just want to go in a little more because we're going to be hitting some of these terms, and I at least want you to know what the block has inside, and then we can go deeper and you won't be confused with that. Now, lastly, let's talk about the blockchain lifecycle here. Now, it starts off by a transaction being initiated. So a user will request a transaction, and then broadcasting will happen. The transaction is broadcasted to the network. After it's been broadcasted to the network, nodes will verify the transaction against the blockchain's rules. So validation comes into play. And then consensus. The network agrees on the validity of the transaction. So it's just consensus, whatever mechanism you put in play. After that, a block forms. So transactions are grouped into a block. And then the block is added to the chain via the consensus. And then we just finalize everything with transaction is confirmed and it becomes immutable. You cannot change it. It is there on the blockchain. Now, that was the end of lesson 1. The assignment is to do some reading. Again, this is the foundations of blockchain architecture. So why not start off with the foundations by research and summarizing the Bitcoin white paper? So you can get a understanding of how Bitcoin was set out to be used and all that good jazz. Finding real world examples of public, private, and hybrid blockchains. I think it's good to find out. You probably already know, but some of you guys may not, to find out what are some real world examples of public, private, and hybrid blockchains. What companies, what blockchains, what are the other companies, the business, just so you can see the difference between them. Some practical exercise is to review the basics of Python. We're going to start in the next week. We're going to start building our first blockchain using Python, putting in some of these things and opening and looking at the block so we can see this happen in real time. Add some transactions and try to tamper with transactions and see how the blockchain reacts. So we can have real hands-on experience and see the blockchain movement in real time. All right, so review Python, just review it. I do have some links I'll put out in the Discord so you can just review it really quick. And then discussion. How does decentralization improve security and trust compared to traditional centralized systems? So I want you to share your thoughts in the blockchain Discord channel about what you think about decentralization and how you see that it is improving security and trust compared to what's already in place with our traditional centralized systems. So just do some research, use some Google, use some AI, and share your thoughts in the Discord. So like I said, next week, we will go over building the blockchain a little more with Python, real basic blockchain, nothing crazy, just so we can see what we talked about, see the Merkle tree, see the block, the transactions, and know how it's kind of structured. Python is going to be really good skills for us to have as we go into our Solidity skills, which is the programming language for smart contracts. So it's good to have a little understanding of Python. You don't have to be, great at it. Just, what a Boolean is, you know what an integer is, you know what a variable is. If you know what those things are, then you're good.